Alright, worksheet number 8. The first one that I had a request on was number 9. And it says it wants to find the sine of 80 and the cosecant of 260. So the first thing I would probably do is I would probably try to draw a picture. There's 80 degrees. 260 would be 180 plus 80, so 260 is the opposite angle in the third quadrant. So this is the sine of 80. The cosecant is 1 over the sine. So I have 1 over the sine of 260. So I look at cosecant being 1 over the sine. Now I just have to decide what's the sine of 260. Well, if this is 80, I've pushed over 180 degrees. The sine of that will be negative. So sine of 80 times 1 over the sine of negative, I'll go negative sine of 80. Because again, it's the opposite of the sine of 80. So if I take the sine times 1 over the sine, I get 1. But because again, these were opposite of each other, I get negative 1. Okay, so you had to realize they were reciprocals, and that 260 was the opposite sign. It would be a negative sign in the third quadrant. Okay? Alright, then on the back, I think the back was a request of all of it. So what you need to know on the first part of the back is you need to know even and odd. The two even functions are cosine and secant. So the cosine of negative theta will always equal the cosine of theta. Because it's even, when you think about the graph, any theta and negative theta will have the same value. Because it's even. It has y-axis symmetry. The sine and all the other four besides cosine and secant, all of those are odd. So the sine of the negative of that theta will be negative sine theta. Okay, those are the even odd things. Then the other thing was the cofunctions. We have a list of all the cofunctions. So if you have the cosine of pi over 2 minus theta, it's the same thing as the sine of theta. Or if you had the other reverse, sine of pi over 2 minus theta would be the cosine of theta. So all the cos go together. The tangent and cotangent go together. The secant and cosecant go together. Okay? So in number 11 then, it says the sine is negative 2/3. So it asks you to find the sine of negative theta. Again, it's an odd, so that will be positive 2/3. We can do this one over here right away. We also need to know the period. So remember, the period of sine is 2 pi. So when you see theta plus 2 pi, it's the same as what I started with, negative pi over 3. The other one really isn't a property, but we can think about if you have a sign that's negative. Let me put it down here. And I add pi to that, it's going to push it up there in the opposite direction. So if the sign is negative here, the y value here has to be positive. So that's going to be a positive 2/3. So I have 2/3 plus 2/3 plus a negative 2/3. These two would cancel out, so I'm left with 2/3. So you got the odd property. You got to know what happens when you add pi, and then you've got the fact that it is a period of 2 pi. So with this one, it's a little bit different because now I give you the sine. I'm asking about things about the cosine. So with this one, we better draw a picture. It's between pi over 2 and pi, somewhere over here. If the sine is 1/5, that means your y value is 1, your radius is 5. So if you use Pythagorean theorem, 1 squared plus x squared equals 25. You should get the square root of 24, which we're going to reduce to 2 radical 6, and it's going to be negative because it's in the second quadrant. So when it says what's the value of the cosine, remember cosine is x over r, so negative 2 radical 6 over 5. The cosine of negative theta, so if I know the cosine of theta, cosine of negative theta is going to be the same thing because it's even. And again, if you want to see that here, what that would mean is if this is theta from here to here, then our theta has to go from here to here. It still would have a negative cosine. And then this one says minus the sine of pi over 2 minus theta. This means the same thing as the cosine of theta. So I want to minus the cosine of theta. Here's the cosine of theta. So if I minus a negative, I'm going to be adding. So again, these two would cancel out. Negative 2 radical 6 over 5. Okay? All right. Then number 13, same kind of thing. We have secant is negative 2. Secant is an even. So I first see secant of theta, it's negative 2. Since it's even, that will also be negative 2. Since its period is 2 pi, that will also be negative 2. So when I put them together, I get negative 6. Cosecant is 5. So cosecant is an odd function. So when I see cosecant of negative theta, it's the opposite of the cosecant of theta. Now this one asks me for the sign. So now I have to know that, okay, if the cosecant is 5, the sign will be its reciprocal, 1 over 5. So when it asks for the sine of theta, that's 1 over 5. And then again, it's odd, so that will be a negative. Negative 1 over 5. So these go away. I'm left with negative 5. All right, so then 15 and 16 are just talk about the pairings. So you have to decide what the value is. So when you think about sine, I always have to kind of draw a unit circle. I want things to cancel out. So I have 1, which is right here. 1 degree, the sine of that will cancel with 359. So I could say, all right, 359 is going to cancel with the 1. 2 would cancel with 358. So I'm left with this sine of 360. It isn't paired with anything. So then I think about going all the way around the circle. All of these sines, all of these angles will be paired with an opposite above it. So anything up here will be paired with something down here. All of those will go away. 1 and 359, 2 and 358. It'll keep going around that circle. The only other thing that won't be paired, won't have a pair, is 180. So if you think about all the angles from 1 to 179, they're all going to be paired with angles down here that they're going to cancel out. So I have this sine of 360, and I also have the sine of 180 in the middle that doesn't have a pair. So then I just have to say, what is the sine of 180 plus the sine of 360? They're the only two that didn't have a pair. Sine of 180 is 0. Sine of 360 is 0. So my final answer is 0. This one's cosine. So now when you think about cosine, 1 degree is going to cancel with 179. Now the x's have to cancel out. So I have 1 and 179. I have 2 and 178. So all of these are going to cancel. The only thing that won't have a pair as I'm going this way around will be 90. 90 degrees won't have a pair. Everything else will have a pair going around. So I just need to figure out what's the cosine of 90 degrees, and that's 0. Okay, and then 17 and 18 again are dealing with the even, odd, and the period. So if I'm dealing with tangent, tangent is odd. So f of a is 2. So f of negative a, when I put in a negative theta, I'll get negative 2. So here I take f of a, which is 2, f of a plus pi. Now this is tangent, so the period of tangent is pi, so if I add a period, I still have a 2. And if I add 2 periods, 2 pi, I still get 2. So 2 plus 2 plus 2 is 6. So this is key right here, that with this one, even if you push it on the opposite side, because tangent has a period of pi, it's still 2. Alright, and then the last one is secant. Secant is even. So when you see f of negative a, you're going to keep what you had. F of negative a will equal the same as f of a, because it's even. And so then f of a was negative 4. Negative a would also be negative 4. Secant has a period of 2 pi, so that will be negative 4. But now we have to realize that with secant, since the period's 2 pi, I had a secant that was negative. So let's say it's right here. If I add pi to it, it's going to put it down here. So the secant's going to be positive. So that one's going to have a positive 4. So these two would cancel out. I'd be left with negative 8. Okay, so this whole back page was even, odd, and period stuff. And I guess there's a couple co-functions. So those are all the things I want to make sure you know from that page.